Hi there. My name is Kaylee Godley, and you can find me at kayleemakes.com and Kaylee Makes Crafts on social media. I've had the privilege to give my cosplay LED panel a few times at some conventions in the United States, and I think this information is incredibly important. I have a very unique situation and a special set of resources that I feel like need to be more available for our cosplay community. I hope you enjoy the cosplay LEDs illumination for costumes and props. A little bit about me. I am from Dallas, Texas, and I am a professional cosplayer. I make about 90% of every single thing I wear for my cosplays, and I've been sewing since 2005. In about 2012, that's when I got into making costumes, and then I got into cosplay right after that. I made some costumes to go to a Ren fair, and then I made a costume from a Lord of the Rings video game that I was playing at the time. Something I would also love to note is that I like to cosplay characters from books. So, one of my favorite authors is Brandon Sanderson, and I love fantasy stories like The Stormlight Archive and The Wheel of Time by Robert Jordan. I also love sci fi. Dune is one of my very favorites, and I will also share that my favorite Marvel character is Loki. Now, I told you that my situation is kind of unique, and it is because of this guy right here. This is my lightning mage. His name is Richard, and he is my husband, and he is an electrical engineer. So, the unique thing about Richard is that he's a great teacher. And once he taught me to solder, he turned me loose and said, okay, bye, have fun. Do that yourself. I'm not going to solder for you for 15 hours. That's going to be your job. So, the ambitious projects that I have worked on, he has empowered me and helped me out along the way. And when I prepared this panel initially, it hit me that it's not fair. It's not fair that my best friend is great at electronics. I wanted to share this knowledge with you, and so it is an incredible privilege to be able to do that. There is one major caveat. I am not an engineer. I am not a programmer. So, knowing those two things, I am going to be explaining our electronics information in multiple ways so that it can maybe click in your mind. Okay, a little bit of an overview and a path that we will be taking through this presentation includes planning your build. Where do we start out? Sample lighting, because we don't have to do everything on hard mode all the time. There's some great kit options. I will spend a decent amount of time talking about how to diffuse light, because diffusing the light is a way that we can get some cool effects to adding LED projects. We will talk about a basic circuit design with some diagrams, electronic skills and supply lists that you're going to need. We will talk about animated LEDs with some programming tips. And if we have enough time, we will get to leveling up those things and putting them together in different ways. So, to start out, let's talk about planning your build. When I am planning my build, one of the first things I think about is which battery should I use? How is it going to fit into the build? How I'm going to charge it? And how am I going to be able to turn off my prop on and off? Like, where am I going to be able to get to the switch? So, how am I going to hide the battery? How am I going to charge it? And how am I going to turn my prop off when I don't want it running? The second question I think about is which part of my prop lights up? And in thinking about that, the next immediate question is how is the light from the LEDs going to be diffused? How do I want the lighting to occur on my prop? And so I want to start out with a few ready options for LED lights, because you don't have to solder at all if you want to put some LEDs in a prop. There are so many neat holiday packs. I usually look for these at places like a hardware store or even a big box store. We'll have a lot of these around the holidays. There are different options here that can run just on AA batteries, which is great. I especially love these icicle looking ones because they can be like a crown, or you can just color them like a Sharpie and then they could be like a lighting up spikes like on a pauldron or something. I've seen some really fun incorporations of tea lights that have the little flickering flame, and you could even use glow sticks if you didn't want to fiddle faddle around with batteries, but those are like a once and done use. Now, there are some kit strips that are available. So if you don't want just an out of the box, like party string of lights, there are some USB options. So some of these are really cool because they come with a remote. So all you have to do is plug in a power supply and then you can change the color of the lights with a remote. There are also under the counter lighting options that are 12 volts that are Bluetooth enabled. So you can use an app on your phone to control the lights, which is really cool. These kits will often come with quick clip connectors, which are just like pushed on, that can save you the step if you don't want to be soldering on LED projects. So you can kind of take a variety of approaches here. So to say like, hey, I want to use a strip of LEDs, but I can look for a kit that has a Bluetooth app, and I can just manage it on my phone. Okay, diffusing lights. Diffusing means to spread out. So there are lots of materials to do this. One of them that is a very common tool is just the thin, clear packaging foam. It's like very flat, translucent foam that I get from packaging, but the bubbles are quite large. And this can create a super nice lighting effect to spread out the little hot spots, which are the dots on the LEDs. You can also look for things like the plastic crystals or icicles. I have even used beads. One kind of material called plastizote is a little bit less common, but it is specifically made to diffuse LED lights and is really great to use with EVA foam projects. And it comes into like a giant roll right here. I would say it's a little bit more stiff than EVA foam, but it is an awesome option. Just so you know, this is a cute baby circuit. It's not complicated and it's not scary. So just trust me, okay? So first, in our circuit, we have a 12-volt battery. This is hooked up with a switch. This is just a tactile switch going into the step-down buck to convert to 5 volts out. Remember that the buck is directional. You got to put it on the right way or it won't work. On our Arduino card, this is our microcontroller. We have the battery and the ground here, and our signal is coming out usually at port 6 on this card. Right before the signal line for our LEDs, I'm using a 300 ohm resistor to help protect that signal line in this case. And then we can go off our merry way to the LEDs. So that's awesome. So our battery is 12 volts. We step down to 5 volts, and our LEDs are running on 5 volts as well for the Adafruit NeoPixels. Now let's look at another real life example. So this is a gauntlet that I've got a strip of LEDs on. So we've got the battery. This is a drill battery that I used, a switch, the step down buck, the card. The resistor is protected underneath the close to the LEDs to protect the signal line. And then we have the LEDs that are actually installed in this EVA foam bracer. Here's another look at the same thing. Battery, switch, step down buck, card, resistor, LEDs. Now let's talk about the different wires we have that are attaching to the LEDs. We've got ground, we've got power, which is 5 volts, and then D in, that's the signal in. In this picture, the white wire is this signal. In other examples that I've used green wire. In lots of my builds, that's just what I prefer. All right. So put a bookmark in that, and we're going to continue for the tools for electronics projects. Number 1, you need a soldering iron with temperature control. I prefer one that also has an auto off feature. it is kind of annoying, but it's a great peace of mind to know that my soldering iron will not be staying on accident. Solder and flux. I want you to think of solder as high temperature glue. Um, the solder that you use will be have a specific temperature where it melts. Mine is about, the one that I'm using now is about 370 degrees Celsius. Very hot, very hot. Now flux is great because flux is like grease for the solder to smoothly flow. So when we heat up the solder, the flux is going to help it flow smoothly and create a beautiful electronic contact. Wire strippers are really great. Make sure that they work for the size of the wire that you're using. Flush cutter wire snips and needle nose pliers. I love the needle nose pliers because when you're soldering, connections get hot and it can be super warm. I like to use safety glasses. Desoldering braid is kind of like a wick, like a candle wick that has flux in it that's made out of braided copper, and it can suck up extra solder that you might have put on too much. Heat shrink is so fun. It's like a tube that shrinks when it's heated up, just like its name, and it is used to stabilize and cover up spliced wires or other connections. Another thing you're going to need is a multimeter, and I'm going to talk about how to use that in troubleshooting here in a couple slides. So another bookmark and multimeter, and we'll talk about that here in a second. So for this first circuit diagram, here are the things that you must have. You've got to have a 12-volt battery for this setup. 22 to 26 gauge stranded wire. That's what I prefer. I use red, black, and green for the power, ground, and signal. Tactile switch, that means it's just you touch it to turn it on and off. The step down buck. And in this case, we are using an Arduino card called the Adafruit ItsyBitsy 32U4 16 megahertz. So if you click on this, follow this QR code, it will give you a page on my website that has just clickable links to all this stuff, and you can go and add them to your cart. We've got a 300 ohm resistor. Remember, that's to protect the signal on the coming from the card to the LEDs. And then you need your LEDs that you're going to buy. Okay, so let's talk about troubleshooting. There are lots of ways to troubleshoot your circuit and your LEDs layout with a multimeter. So a multimeter is a tool that you can use to measure lots of things. One of them is the resistance. Resistance means how difficult is it for the electricity to get from point A to point B. If it's low resistance, aka none, from point A to point B, that means that the electricity is flowing, that the circuit is closed, and it can flow from point A to point B. Now, we can use that fact to say, hey, electricity, are you flowing from point A to point C? And if it has high resistance, we know that it is not flowing from A to C. So ohming out your circuit, that's like a whole skill set, like a whole troubleshooting skill set, just learning how to ohm out your circuit without the power on at all. You're testing point by point to make sure that you don't have any shorts anywhere. Make sure your battery's charged. And one thing I like to do is to get a little stick, like an orange stick, and to poke and wiggle things, because if I poke something and my lights kind of flicker, then I know that the connection might not be very strong. So I can take out my battery, redo those solder joints, and poke and wiggle that again. And a lot of times it will improve the reliability of the project that I'm building. Now, this is a gem of piece of information that you're not going to know unless you're an engineer, because it's like so basic and intuitive, but it's not thought about commonly. So to improve the reliability of your circuit, you can run power everywhere. Power does not care. It can bounce around all over your LEDs as much as it wants to, but ground and signal must follow the same path, or there can be problems with interference. So you can run power any which way to be redundant. And that's an awesome way to improve reliability. So where do you draw the line? So if I need to diagnose a problem on my LED panel using a multimeter with the circuit on, when I've got power to the circuit, that's when I need to stop and get help. Because these are the cases where I can cook my hardware or I can shock myself. So this is when I get help, because using the multimeter on something that has power to it, you can short things out and cook everything. And that's really expensive. Okay, we are going to be getting into Arduino programming. For the first circuit example, I have used something called Arduino IDE software. Now, this is not the most intuitive thing ever, but I have solved an awful lot of problems for you. And so I am referring you to the specific library you need for this card. Make sure you have the correct library when you are adding a chip on this program. If your chip doesn't want to talk, try a different USB port on your computer. Try a different cable that's meant for data and power. Some USB cables are only for charging, and those are not going to work. Sometimes I've even had to try a totally different computer because for whatever reason, my card didn't want to talk to the IDE software on that particular machine. So the cool thing is, you remember that I am not a programmer. I'm not a developer. We can use and alter open source functions and scenes, which is so cool. All right, so here are a couple things that I have figured out and I would like to share with you. For color changing effects, I have used the rainbow and rainbow cycle functions and color wipe and color strip functions. Now, the cool thing here is that we can limit the rainbow to say, hey, I only want cool colors, or I just want yellow and green, or I want the warm colors down to like a deep blue purple color. So we can limit part of the rainbow, so we're not going all the way around the color wheel. And we can swap the direction here on using these functions also. So that is a great QR code off to some specific directions on how to edit those functions a little bit. Now, would you like more? More options, more ideas. I hope so. So the great news I have, before I tell you the great news, let's just pause here and appreciate my fantastic soldering job here on these pins. I'm extremely proud of that. All of the soldering joints are very shiny and precise, and they're not goopy or fuzzy or dull. So that's what you're going for. The beautiful pins at like 9 and 10 that are really in focus, that is just perfect. All right, so here's the great news. Kamui Cosplay has updated a book in 2023. When I learned this, I was using her old book, and just because technology grows and changes, lots of things were out of date. This book, we can do some fun stuff with LEDs, sound effects, and also with an accelerometer to understand motion. We are going to be talking about a new set of hardware, a different program to manage our code as well. So this is going to be using Circuit Python software. I do think it's a little bit easier to use than Arduino IDE. However, both programs are kind of similar to MATLAB. The chips we are using, there are two in this case. One is the PropMaker FeatherWing. This is where the hardware lives. This has the connection for the speaker, the LEDs, and it has the accelerometer on here as well. Then for the Feather, we are driving our power and the programming here. This is the memories. Another major difference with this circuit design is that we are using 3.7 volts in our battery. And now that is it's a lot less than a 12 volt battery. So keep that in mind. So this is not great for a ton of LEDs, but it might be awesome for a prop that, has a trigger effect or that just turns on at a certain time. So it's kind of fun to be more interactive. This is a chip that's super great for that. Okay, so here are some examples. So this is a real life setup. We've got the speaker, LEDs, the accelerometer is in the board. and our switch and battery. So I do want to point out this comes as two pieces. You buy them as individual items, and then they need to be soldered together. These two fit together in only one way. They were super kind in designing this. You can only fit the pins together in one orientation, and that's how they go. Now, I love this next slide because I've got another supply list for you. So you can just add these to your cart from Adafruit. I also have listed out some batteries. If you cannot find this exact battery, a different size 3.7 volt battery would work just fine. And these come with, make sure it comes with a charger. Now, I have some extra cables on here since we're doing more cable connections that will specifically work for the speaker and the NeoPixels. So that's awesome. Good to know. All right, now here are some more awesome resources for CircuitPython. So you want to grab the stable release for the Feather M4 Express. So that is basically our programming language we're using. We are going to edit that code using Mu Editor. You can grab that here at that URL. And now we begin the copy and paste festival, where we can run with this and learn the programming. But remember, you don't have to write code from scratch. You can just edit and change what's already there, which is super awesome. I do want to point out this incredibly in-depth guide on Adafruit about the Feather 4 Express. So I've linked that here as a resource for you too. As a note, Kamui Cosplay, that book is fantastic. The new one that's from 2023. She also has some code examples for some of the props that are in the book. So that's a super fun way to learn to say, hey, I want to make this project and do something similar. And we've got the code already there. So that is fantastic. Okay. That is the conclusion of my LED panel. And I want to say a huge thank you for you all who have come to my talk in the past. This keeps getting better and better over time because of your engagement and investment in this. So thank you so much for your time. I hope you have an awesome day, and I'll see you at the next convention. Bye.